Good evening and welcome to Tinkering with Edkelar. Previously... And now, the conclusion. Yikes! The audio socket is a bit out of shape. Making sure that it is not too tight and also not too loose. The RF socket is tarnished. Again, the wire brush gets it good and clean. I got replacements if that doesn't work. And after liberating the speaker, I can take care of the cone. Thanks to Cheetah for pointing out a video with an interesting idea for a repair. Link below. Coffee filter and wood glue. I'll give it a try. Sadly, my speaker is still well connected to the frame, so I had to work around that. I don't think I need to cover up the patches on the backside, but a dab of paint on the front makes the repair blend in a bit better. Bummer. The filler seems to have shrunken a bit after painting. It was perfectly flat when I primed it. Too late now to start that over. I have to repaint the entire panel to avoid any visible artifacts. It's just lab equipment anyway, so I'll keep it with that slight dimple. Putting on the decals next. Again, not 100% perfect, because they are glossy when viewed from the wrong angle, but much better than originally. After measuring a few capacitors for leakage and checking up on some resistors, it is getting very clear. This will be another rebuild. At least it uses regular wiring, not the cloth style, so I can use regular ones as well. The tube sockets are the last parts that need to be freed from sticky wiring and unreliable components. The signal path uses shielded wires, and like the rubber grommets, the insulation layer is crumbling away. And finally, adding the first components to it, the input socket and speaker, complete with cleaned and straightened mesh. The speaker connectors also needed a bit of polishing. I also used contact cleaner on the inside. And with the switches and power outlet, it starts to look the part again. The new filter capacitor is easy this time. All 4 of the new ones fit nicely into the form factor of the old case. The negative leads are common and get some insulators to prevent any shorts, even if they move. Eventually, I need to make some reverse can opener to close those cans again. Bending over the edge works fine, but it looks a bit meh. After adding the cleaned tube sockets back to the chassis, it's rewiring time. I follow the picture in the original build guide as closely as possible, and after finishing the primary and heater side, I check the rectifier tube. Yes, DC. Of course, I also use shielded wiring when needed. Finishing the DC supply rails next. And as always, I build and test the circuit one tube at a time. adding the handle to the case and putting on some new rubber feet. I don't have anything to rivet in that size, I might replace them later. I really like the look of the replacement knobs I found. Spiffy. But they are a bit shallower than the original ones, so 2 of the 3 have quite a gap between the panel and the knob. Time for some fine tuning. The watt meter is still my biggest worry. How would the 240 volt instead of the 110 volt behave? If my understanding of it is correct, then the second transformer should act as a current shunt and produce a proportional voltage in the secondary, which will be rectified, and the tuning potentiometer applies that to the grid of the I-tube. Since we need about half the current for the same power, I think it should read about twice the wattage, but otherwise work fine. I'd lose a bit on the lower end, but without rewinding that other transformer too, that's all I can expect. To calibrate the watt-meter scale, I needed some loads. Well, I don't have any high power devices with an IEC socket, so let's build an adapter. I took a self-contained power outlet, known around here as an on-the-wall outlet as opposed to the usual in-the-wall, and crammed a strain relief, a fuse holder, and, totally unsafe and certainly not recommended, a set of banana plugs into the case. Now I have an IEC to whatever I need adapter, or to quote Big Clive, a death adapter. This is certainly a "don't try this at home" moment. I just do that because I have stagehands here to act as a stunt dummy. With the adapter, I can now plug in my digital watt meter and also a test load to calibrate different wattages. The range is certainly shifted, but it works and gives repeatable results. The unit originally came with 2 probes, an RF one and an audio one. The RF probe has a few components in it: a DC filter, a rectifier diode, and a resistor divider for termination. At least I think as much. If I'm off, please comment below. I'm putting the components together on a strip of perf board. Now to the probes. I have to make those from scratch. First, I take some antenna cable I had around and add the plugs on one end. Then I design and 3D print some spacers. I make the probe body out of copper heating pipe again. I really like the look of the nickel-plated one for the Super Probe build. The tips are shown to screw in. Maybe a replacement strategy if one breaks? I follow the idea to make a sleeve and tip combo. The rear cover has a hole with a nice spring I found. That should protect the cable. I also add a grounding lead with a crocodile clip. The cable goes through the spring, the shielding is looped around the spring wire to keep it secure and connected to the grounding lead. The spring is then put into a retainer ring that fits into the tube. The end cap puts a nice wrapper around that end and also connects the spring to the case for shielding. On the probe tip end, I soldered in a piece of wire to the little adapter tube and glued it to the cone part. The pieces are held together with M2 screws, which also pinch the retainer ring to make sure the spring stays where it is. Putting it all together, here's a quick rundown of the circuit. The RF input section is implemented with a 12C8 tube and a 2.2 megaohm input resistor. Should be quite nice. The RF switch turns off that section by shorting the input to ground. The next stage is also the first stage for the audio input. A 12SH7 takes the audio from the gain potentiometer and amplifies it. Some output is directed to the I-tube as a visual indicator. The final stage is a 12A6 as the power amplifier stage. It drives 1/2 of an audio transformer. This is done so you can hook up an external push-pull circuit to it for testing as well. Bottom line, this one unit provides pretty much all the required ways of converting any electrical signal in an AM radio into audio. Neat! There are two more useful features. Noise detect mode will add about 180 volt of DC to the audio input. Similar to phantom power, just avoid touching it. In this mode, when putting the DC across components, bad ones should make noise and good ones should just go click. The last mode, of course, is the wattmeter. The current sense transformer uses the two diodes in the 12C8 to rectify the voltage, a tiny capacitor as a buffer, and it feeds into the I-tube to show an almost closed iris when the power consumption matches the calibrated potentiometer value. And that's it! A mostly new Heathkit T3 signal tracer ready for action! I can't wait to start on my next tube radio project. I have 2 of them in my queue for next year. I hope you enjoyed this rebuild project. See you next time! I managed to score one of those Heathkit. I got mail! Coming!